I'll be sending you some questions just within a minute in the group. You will receive all the questions and then we'll do revision for it. Okay, so you can check your group. You have got the questions over there. However, I'll be sharing here on the screen also. Okay, so did you get the questions? Chavan?
Yes, sir.
So it's a very good trick. I caught it.
Did you send it in the WhatsApp?
Yeah, I sent it, but I caught you. So now we'll start with the class. So everyone is here now? Let me check out once. Okay. So Prince, Kerishika, Orosmith. Okay. All of you turn on your cameras. Chavan, Orosmith. So first of all, let me clarify. If anyone has any doubt in the chapter motion, do you have any doubts in the chapter motion? No one?
No, sir.
No. Okay, so let's see. So I hope you can see the questions. So in which state of a body its position does not change with respect to the reference point? So what we will call that state?
Rest.
Yeah, we call that state to be rest. And what is the state of motion? Yeah, Chavan Kaushik, what is the state of motion? Chavan. Chavan, can you give the answer? What is the state of motion? You are muted. Unmute yourself first.
Yes, sir. The state of motion is like defined by its velocity, right?
No, you are not concentrating. How do we define the state of motion? Prince, how do we define the state of motion?
We can.
Sir, by its speed.
No, not only by speed. We define the
Sir,
state of motion by
speed
the change of
and
position.
direction of motion.
Speed and direction.
No, by the change of position. If a body changes its position with respect to time, so we say that it is in the state of motion. So which physical quantities have only
Sir,
magnitude
that's
but
basically the same thing as speed, right?
no, you
Distance
do
or
not.
something.
Speed is a different quantity. How do you observe it that it is moving. Basically, you observe its position changing. If it is changing its position,
It's
then you
basically
say
like the distance it took by time, right? We can also call that speed.
we can call that speed, but see, different terms have different meanings. If you use a different term, it will create an ambiguity in your answer.
So what's the answer for this one?
The answer is that if there is a change of position with respect to the reference point, then we call it as hello. So basically, if the position changes with respect to time, so the change of position now you to measure the change of position you use different other quantities, like you can use
So
distance,
basically,
you can
change
use
in position
displacement.
is distance.
Yeah, you can use distance, you can use displacement, you can use speed, you can use velocity. So that is a different aspect.
Sir, displacement is the same thing as distance being covered, but in a different way. No, but
No,
no,
the
not
thing,
like that, but like.
the things have totally different meanings in physics. Distance and displacement have totally different meanings. Okay, and their physical aspects are also different. So as of now, you have just studied about speed and distance, and just a little bit only about distance and displacement. So do not think that it's the same thing. It's okay. It's only you can say that if the object is moving in one direction. Okay? So if the object is moving in one direction without changing its direction, so it will be a speed and velocity will remain the same. The magnitude of both of them will remain the same. Okay. So speed and velocity, they are the measure of how fast an object is moving. Do not go and the definitions have some keywords. So see, what is a circular motion? Prince, what is a circular motion?
Sir,
Yeah, what is a circular motion?
sir, which get rolled um,
Yeah.
like a tire of wheel of cycle.
No, give the proper definitions. This is what you are lagging, and that is why you do not score marks in your written exams. And Rishika, can you give the proper definition of circular motion?
Sir, is there a object moving around the circular path?
Any object moving in a circular path is said to have a circular motion. If an object is moving in a circular path, then we say that the object is having a circular motion. Okay. So what is circular motion? The object is moving in a circular path. Then we call it as the circular motion. So do not use your other words. Right? And what is displacement? Now again, Chavan Kaushik, what is displacement?
Wait, sir, can you repeat it one?
Displacement, question number 6. What is displacement?
Displacement It's basically like going from one point to another in the thing,
Hmm?
like distance from one point to another, or
Smith,
like
can you define
change
displacement?
from, huh?
Smith, can you define displacement?
Yes, sir.
See, Chavan Kaushik, you know everything, but you are not putting them in words. You know what is displacement. I don't say you know what is motion, you know what is rest, you know what is circular motion, but you are not putting them in proper words. Try putting them in their proper words or read the context, read the answers. Or in your book, read the definitions which are given. So the next is what is displacement? What is
So we
displacement?
can final position minus initial position.
The shortest
Yeah,
distance from initial point to final point.
the shortest distance between initial and final position is called as the displacement. Okay. Why we do not, if see currently you say that you can find it as final position minus initial position, of course it's the same thing, but then the terminology will change. If you are defining like that, then your terminology will change. Suppose if you are obtaining something like this is an xy plane, an object is moving in this xy plane. It started from here, it started from A, and from A it moves now to B. Let's say it moves to B. So how you will obtain its displacement now? Now it is in two dimensions. So how you will obtain its displacement? Let us say the initial position of A was, let's say it was 1 comma 3. This is the initial position, and the final position B, it's uh, it's 5 comma 8. Let us have this. Now what will be your displacement then? So how you will obtain the displacement? Final position minus initial position. John Kaushik?
Yes, sir.
So what will be the displacement? Can you tell the displacement here?
Sir, is it -2 comma -5?
No.
-2 5 -2 5.
So what's the meaning of that? Negative 2, 5. What does it mean?
That's the shortest distance
No.
between final position and initial position.
But is this distance? You said negative 2 comma 5. Is this distance?
Yes, sir.
So how can you measure it? How many meters is it? Can you say this is meter? This is
I
certainly
don't
not.
know, sir.
See,
Yeah.
we say, that definition you are applying. So that is why I'm telling you, use proper definitions. Your proper definition for displacement is you have to find the shortest distance between A and B, and the shortest distance between A and B can be computed from A and B like this. So this is the shortest distance. Okay. Now you can use your Pythagoras theorem like this. So here so that is why it is not only final position minus initial position. You will learn a lot about displacement in higher classes. Okay, so in two dimensions, it is vectors. You will study about the vectors in detail in your class 11, in your grade 11. So currently, if you are said that what is displacement, it is the total distance, or it is the shortest path between initial and final position, or the shortest distance between initial and final position is called as displacement. Got it? So remember it. Try to remember the things. It's the shortest distance between initial and final position. Okay. So I hope now you are clear with the definitions. So next time I should not see any problems with the definitions. Oro Smith, can you define displacement?
Shortest distance from initial point to final point.
Final. Yeah. Name the kind of motion of a body when it travels equal distance in equal intervals of time. So what type of motion does it
Uniform
call?
motion. Uniform
Which
motion.
motion?
Uniform motion.
Uniform motion.
Okay. It's uniform motion. Then what is acceleration? What is accelerated motion? Yeah, Harini, what is accelerated motion? Harini, what is an accelerated motion?
Oh, yes, sir.
What is an accelerated motion?
Sir, if the velocity keeps changing.
Yeah, a changing when the velocity of an object changes, then we say that it has an acceleration. Okay. Then device called odometer in the vehicle's measure. So what does odometer measure?
Sir, the distance.
Distance. Which of the following are all scalar quantities? So of the options given, which option represents all scalar quantities only?
Sir, speed, distance, time, force.
Each force a scalar quantity?
Sir, what?
Each force a scalar quantity? See, the effect of force, it depends on the direction of in which it is applied. Okay. For example, two people pushing a ball. Okay. Suppose if you have two people pushing this, so if two people are trying to push it, so the result depends on in which direction they are pushing it.
Sir, is it D?
So option D says speed, distance, time, and work. So we know that speed is a scalar quantity, distance is a scalar quantity, time is also a scalar quantity, and work is a scalar quantity which we have studied in the chapter work. Okay,
Yes.
so work is also a scalar quantity and hence the option D. Now, which of the following are always positive?
Sir, is it speed?
Yeah, speed is always positive. Displacement and acceleration, it can be negative. They are vector quantities. So all the vector quantities can be positive or negative or can be zero. Then the speedometer measures. So what does the speedometer measure? Average speed, average velocity, instantaneous speed, or none of them? Yeah, any answers?
So instantaneous speed.
Instantaneous speed. So how can you say instantaneous speed? And why not average speed? Yes, why not average speed? Why only instantaneous speed? See, when the speed is high, so it shows high speed. When the speed is low, so it shows low speed. It does not depend that whether earlier we were at a high speed or a low speed. Are you getting? So it measures the instantaneous speed. The moment you are at 90 km per hour, it will show you 90 km per hour. It does not matter whether the vehicle was standing from last 10 days. Okay. So the speedometer measures the instantaneous speed. It also cannot measure velocity. Then acceleration towards the center of a circular path in which the body is moving is. So what name is given to the acceleration that act towards the center of the circular path? Or Smith?
Sir, is it option C?
Yes, sir.
Sir, is
Okay,
it
so
option C?
Yeah, option C is correct. Centripetal acceleration. Okay, one more question. What is the work done by the centripetal acceleration? What is the work done by the centripetal acceleration? I have explained this many a times. See, observe the circular motion. In the case of circular motion, the object moves in a circle, and the centripetal force it always acts towards the center of the circle. Okay. So when an object is moving in a circle, it has its displacement tangential to the circle. So what is the angle between force and displacement? What is the angle between force and displacement? Yeah, I am asking Rishika, what is the angle between force and displacement in a circular motion?
Sir, is it 90 degrees?
It's 90 degrees. So what will be the work done?
0.
0. So work done by the centripetal force is always 0. Remember, this is a very high concept. If you keep this in mind, you will be able to solve numerous number of problems. That work done by the centripetal force is always 0. Okay. Then, so that means the centripetal force, it cannot accelerate the object. The centripetal force cannot accelerate it. It cannot increase the speed, but it can change the velocity only. It can just change the direction of velocity. Okay, it cannot change the speed. The centripetal force cannot change the speed. Now, see, the area under the velocity time graph represents a physical quantity whose unit is same as that of. So again, think of this. First of all, what does area under the graph represent? If you find the area under the velocity time graph, so what does it represent? Which physical quantity is represented by it? Yes, which physical quantity is represented by it?
Sir, is it acceleration?
Yeah.
Is it acceleration?
Again,
Sir,
no. Acceleration is obtained by the gradient of the velocity time graph. Okay. That means the slope of the velocity time graph gives you the acceleration. So which one of them? The area under the velocity time graph represents, what does it represent? Okay, see, just a trick over here. I'm giving you one trick. And let's see if you are able to solve it out. This is a hint, not a trick. This is a hint, you can say. So let's have this velocity time graph. Velocity time graph. Okay. And it has something, the velocity time graph is something like this. Whatever shape it can have. Okay, this is a velocity time graph. So if you find the area under the graph, the area under the graph will be
1 by half it.
yeah,
1/2 BH. Yeah.
1/2 BH, right? So see, this is your base, which is our time. Base is equal to the time. And this is velocity or height. The height of the triangle is equal to the velocity.
Sir, you didn't give the numbers.
Yeah, I didn't give the numbers. But what quantity if you get if I multiply 1 over 2 multiply base multiply height, where base is equivalent to velocity and height is, sorry, base is equivalent to time and height is equivalent to velocity. So what quantity you get if you multiply velocity and time? Speed into time. If you multiply speed and time, what do we get?
Distance.
Distance. So what does the area under the graph give you? The area
Half
under
of
the velocity.
distance.
Yeah, no, not the half of the distance. This is the distance. Okay. So area under the velocity time graph, it will give you distance. Right? It will be numerically equal to the distance. So now come to the question. See, the area under velocity time graph represents a physical quantity whose unit is same as that of. So the unit is same as that of. So it will not be this as area. Since we measure the area under velocity time graph, so its unit will be meter. Okay, its unit will be meter. That's distance. And so area has units meter square. We want something which has the unit meter. So this has the unit meter square. Velocity time graph, the area under velocity time graph will be in meter. Acceleration is meter per second square. Velocity is meter per second. And what about the light year? What unit does light year have? Can anyone tell light year? Or Smith, what is a light year? Harini, what is a light year?
Sir,
So
is
it
it
will
like
be like
light traveled in a vacuum?
Yeah, the distance
measurement
traveled by
used
light
through
in
which light
vacuum in 1 year.
travels.
See,
So this is
1
light
year.
year is actually a unit of distance. So this is distance. So it will have the SI unit meter. So the light year and area under the velocity time graph will have the same units. So your correct option is option D. For a distance time graph parallel to the x-axis, we interpret. So if you have, again, read the question, you have a distance time graph parallel to the x-axis. So what do we interpret from this? Will it be uniform motion, non-uniform motion, object at rest, or none? What will it represent? You have a distance time graph parallel to the x-axis.
Sir, uniform motion.
Yeah?
Sir, uniform motion.
Okay, see the graph. This is your distance, right? So I write here distance and time. So draw the graph and see. If you do not remember, draw it. So this is the distance time graph. This is what the question is talking. We have a distance time graph such that the graph is parallel to the time axis.
Sir, is it rest?
Yes, now you are correct. It represents rest. Okay.
Sir,
So,
but in a velocity time graph, it's uniform motion.
yeah, in the velocity time graph, it's uniform motion. Aman, can you turn on your camera? Is it possible? Okay, see. So, got the answer for the seventh one. For a distance time graph parallel to the x-axis, we interpret the object at rest. Hence, the option will be option C. Correct option will be option C. Now, if acceleration and velocity are in opposite direction, then what will happen? If acceleration and velocity, they are in opposite direction. So think of any situation. Aman, can you think of any situation where we observe that the acceleration and velocity are opposite to each other? Yeah, Aman, can you tell any situation?
Sir, which question?
We are at question 8.
Yeah.
So can you tell if acceleration and velocity are in opposite direction, then what will happen?
Sir, is it B?
Yeah, it's correct. The correct option is B. The speed decreases. If the velocity and acceleration are in opposite directions, so the speed decreases. We see certain example. For example, suppose if you are cycling and you are moving towards the right. So here, consider that you are moving towards right. You are cycling and moving towards right. So if you are moving along this direction, so this will be your direction of velocity. Okay, so you have your direction of velocity in the positive direction. Now let us suppose you have an acceleration in the opposite direction, and to have an acceleration in the opposite direction, suppose that your friend starts pulling you back with a certain force. So if your friends pulls you back with a certain force, so you will have an acceleration in the opposite direction. Your acceleration will be opposite to velocity. So
Sir,
now
but
the
if
pull.
the acceleration is greater than your speed, then you will be pulled back.
Okay. So how can you say that the acceleration will be greater than speed then?
No, I'm saying supposing if the acceleration is greater, then you will be going back, right? If your friend's thing is going faster, then you will go back
So
with
of
them.
okay, so even if the acceleration is small, then also you will go backwards. If he is constantly applying with the constant acceleration, so then also you will go backward. See what will happen. If a similar situation, just like your friend's one, a similar situation you experience in everyday life, that is throwing a ball in the upward direction. So if you throw a ball in the upward direction, suppose if you have a ball and you throw this ball in the upward direction. Okay. So you are giving it an velocity in the upward direction, but the gravity is giving it an acceleration in the downward direction. Okay. So whatever be your velocity, you give it a small velocity or large velocity, the ball will first go up and then come down. Right? So it will not depend on the magnitude of the acceleration. If your friend pulls you with a greater force, of course you will stop quickly and then start moving in the backward direction. That will happen. Okay. So understood? The answer for this is speed decreases. That is your option B. Now see question 9. When the speed of a body decreases, just 1 second. You see, when the speed of a body decreases with time, then the distance time graph is. So how is the graph when the speed of a body decreases with time? The graph is parallel to x-axis, has positive slope, has negative slope, is parallel to y-axis. So which of them it will be possible? The speed of a body decreases with time. So can you draw the graph for this line? All of you draw the graph for this question number 9. What type of graph you will get for this question number 9? Draw the graph in your notebook. For question 9, draw the graph.
Yes, sir.
Okay, so draw the graph. Draw the graph
Yeah.
of the speed decreases with time. Okay, so how do you get the graph? Is it parallel to x-axis, or does it have a positive slope or a negative slope, or is parallel to y-axis?
A negative slope.
It has a negative slope. So you see, you only solve the answer, but you have to use your pen and pencil. Okay, draw the graph and then you'll get the answer. Everyone got the answer? Or Smith, you also got the answer?
Yes, sir.
Did you draw the graph?
Yes, sir.
Okay. So see, now similarly answer question number 10. A particle covers half of a circular path of radius r. The displacement and distance covered by it. So draw the diagram and tell the answer.
So you don't even need to draw the diagram for this one.
Okay.
I think it's just 2 pi r then comma 0.
So that is why I told you to draw the diagram. Draw the diagram and then tell the answer. Draw it as per the question and then tell the answer. And now you'll also only tell. Yeah, Chavan,
Oh, okay. Okay. I got it.
got it?
Yes.
Okay, so now what's the answer?
Pi r half comma 0.
The 2R and pi R.
Yes, the answer is
Wait,
2r
how
and
is it
pi
pi
r.
r though? I don't get it.
It's half the
Pi R
circle.
is the distance covered by it.
Okay, see, this is the diagram that all of you are getting.
Okay, that's why diameter then 2.
Okay, so first point will be the displacement and then the distance.
Oh yeah.
As it says,
Okay, 2r then pi r makes sense.
okay. So Chavan, you're losing points. Now see for the assertion region questions. For question numbers 1 to 6, two statements are given. One labeled as assertion and the other labeled as region. Select the correct answer to these questions from the codes A, B, C, and D. Okay, so you will tick A if both the assertion and region are correct, and also the region is correct explanation of the assertion. You will take option B, or you will say that the correct option is B if the assertion and region are correct, but the region is not correct explanation. And if assertion is true but the region is incorrect, then C. And if assertion itself is false, so you will have option D. So see the first one. A body is said to be in a state of rest when its position does not change with respect to reference point taken into consideration. So first of all, tell who will tell? Aman. Aman, are you there?
Yes, sir.
Okay. Aman, so tell is assertion correct or not? Tell whether assertion is correct or not.
Sir, where's the assertion?
Yeah, is assertion correct?
Sir, where is it?
First question, the very first question. A body is said to be in a state of rest when its position does not change with respect to reference point taken into consideration.
Sir, is it B?
Okay, see, I'm saying, is assertion correct or not?
Sir, assertion is correct, yeah.
Okay, assertion is correct that a body is said to be in the state of rest. Now, the second point, a body is said to be in the state of motion when its position changes continuously with reference to a point taken into consideration. So assertion is also correct, region is also correct, and it is the correct explanation also. So it shall be the option A. It is directing the assertion. So hence the correct option should be A and not B. Now see the second one. Chavan will answer now for the second one.
Sir, can I answer some other?
There is the second question, option B.
For the second question, speed and
Sorry,
distance.
sorry. The second question is option A.
Okay, speed and distance are considered as scalar quantities. That's true. Speed and distance are the physical quantities with only magnitude but no direction. Yeah. So that will also be option A. Okay. Then for a circular motion, third one. Chavan, now you will answer third one.
Sir,
Yeah.
uh, can I, can I answer it later? I am actually kind of busy with something.
Okay. So Harini will answer now. Harini, third one.
Yes.
Third one, can you answer third one?
Yes. Sir.
Yeah. For circular motion, displacement can never be zero. Is it correct?
Sir, A and B both are true, but A is not the correct explanation of R.
R has to be the correct explanation of A.
So I'm telling it's not the correct explanation.
Okay, see, yeah, it's so is assertion correct? For circular motion, displacement can never be zero.
Oh, sorry, sir.
False.
It can
False.
be zero. It can be zero.
It can be zero, so you are getting assertion as false, and assertion as false was the only option D.
Sir, for circular motion, displacement will be zero if it's always like a full one.
For circular motion, displacement will not be always zero, but it will be sometimes zero.
Sometimes.
Yeah, sometimes it can be zero. It's not always. And okay. The fourth point, the measurement of distance traveled by a body per unit time is called speed.
Sir, is this also A?
So that is correct. And region is speed is calculated by using the ratio of total distance to the total time taken. Okay. So it's correct. Both are correct, and region is implementing the
But sir,
assertion.
total distance traveled by total time taken is average speed, right, sir?
Yeah, that is the average speed. Okay. So that is how you also calculate the speed. It's calculated by using the ratio of. Okay, so then that is your average speed and not just the speed. Fine.
Yes, sir.
So I think it should be assertion is correct, but region is incorrect. Okay, region is incorrect. It's how we compute the average speed. Average speed is calculated by taking the ratio of total distance traveled to the total time taken. Then fifth one, uniform circular motion is an example of accelerated motion. Is it an Harini? Is it an accelerated motion? A uniform circular motion? Is it an accelerated motion? Yes. Any answers?
Sir, is there option B?
The uniform circular motion is an example of accelerated motion. First of all, tell, is this correct? Chavan, is this assertion correct? Is the uniform circular motion an accelerated motion?
Which question, sir?
We are on the fifth question.
Uniform circular motion is accelerated motion. Center body in a circular path.
Yes.
There.
Yes.
Sir, I think what is
Sir, is there option B for this
I think
question?
A might be correct, but R is wrong.
Okay, see, A is correct. Uniform circular motion is an example of accelerated motion because velocity changes, but speed does not change. Okay, so it's an accelerated motion. If a body is moving in a circular path with uniform speed. So if a body is moving in a circular path with uniform speed, then it is said to be executing uniform circular motion. Okay, so this
Sir, is
is
there
also
option B?
correct.
Sir, is there
Okay,
option B?
A body moving in a circular path
that's
with
both are
uniform
correct.
speed. Okay, so
Both are
both are
correct.
correct, but the region is not implementing the assertion. Okay, again, the region does not explain that why the uniform circular motion is an accelerated motion. Okay, so both assertion and region, they are true on their stands, but the region is not explaining the assertion, and
So I'm
hence,
right.
yeah. So which option will it be?
It
Sir,
will be
option B.
A is true and R is false.
Yeah, it will be A is true and R is false. Fine. No, A is true, R is true, but
Sir, option B.
R does not explain. So it's option B. It is option B. Okay. When a train approaches a railway station, the train driver applies brake. So retardation or deceleration is seen in non-uniform motion during decrease in velocity with time. So first of all, is the assertion correct? When a train approaches the railway station, the train driver applies brakes. Yes, the train driver applies the brakes. And why? The region statements retardation or deceleration is seen in non-uniform motion during decrease in velocity with time. So this is incorrect. Retardation or deceleration can be seen even with a, okay, it can be seen non-uniform motion only during decrease in velocity with time. That's correct. So both are correct, but the region does not implement assertion. So here it will be option B. Okay, anyone is there who is finding any problem in solving assertion and region type of questions? Like you are not able, you are confused between whether it will be option A, B, or C. Anyone who is not able to decide can tell so that I'll explain how you go about solving these. No doubts here?
No, sir.
Okay, so I think you can solve that. So see this, you have a passage-based question also. See, currently you are getting such type of questions only in your exams. So that is why I got these questions for a practice of the topic. So see, read the following and answer any 4 questions. So all motions are related to some frame of reference. Saying that a body is at rest, which means that it is not in motion, merely means that it is being described with respect to a frame of reference that is moving together with the body. For example, a body on the surface of the earth may appear to be at rest, but that is only because the observer is also on the surface of the earth. Read it. If you want to read it, you can read this. I'll give you just 2 minutes. You can read this, and then we can start with the question answers from here. So reference point refers to the point to which point we call as the reference point.
There is it option A, from which the object starts moving.
No, it's option 4. It is a point in space with respect to which the position of an object is expressed. Okay. So it is your option B. Okay. Then rate of change of displacement is called. What do we call as the rate of change of displacement as? One quick. Aman. Aman, you are not responding. Even if you are here,
Yes, sir.
all of you should be responding. So rate of change of displacement is called
Sir, pardon.
velocity. Rate of change of displacement.